Okay, so one thing I did after yesterday was that I went and I refactored my code because I wasn't that happy with how it ended up looking. So I'll just show you that really quick. Um, the packet I mostly left the same. I made the value an optional int. Um, but the thing that I did was that instead of having a string and just jumping through it manually, I created this bit stream class where I have, the underlying bits as a string and then an index, and I just allow myself to read some number of bits off of it and increment the index. And so that way, you know, um, everywhere where I was, let me show you. Um, so I had all these cases where I was basically like, you know, read this, start, then add 6 to start, whatever. Plus I was using bytes when it was really bits. That was stupid of me. Um, but now I can just do the way it's written. I have this bit stream. I just read 3 bytes from it, read 3 bytes from it. It's much cleaner. So the reason I did this is because I had a sense that they might ask us to um, re reuse this work because this is the kind of thing that they seem to like doing multiple times. So we'll see. Could be wrong. Finally, to decode the else message, hi, the message says you can continue to search for the search keys. How do you use what appears to be a large ocean trench? Get the keys fallen into, you better send a probe to investigate. The probe launcher can fire the probe with any integer velocity in the x and forward directions. For example, an initial x y velocity would fire the probe straight up, well, 10, 1, fire the probe forward at a slight downward angle. Probe's x, y position, then it will follow some trajectory moving in steps. On each step, the changes occur in the following order. X by x velocity, y by y velocity. Due to drag, the probe's x velocity changes by 1 towards the value 0. That is, it decreases by 1 if it's greater than 0. Okay. Due to gravity, the probe's y velocity decreases by 1. For the probe to successfully make it into the trench, the probe must be on some trajectory that causes it to be within a target area after any step. The submarine computer has already calculated this target area. For example, that. This target area means that you need to find initial x, y velocity values such that after any step, the probe's x position is at least 20 and most 30. Given this target area is 7, 2. In this diagram, S is the probe's initial position, 0, 0. The x-coordinate increases to the right, and the y-coordinate increases upwards. In the bottom right, positions that are within the target area shown as t. After each step, the position of the probe is marked with pound. Another initial velocity is 6, 3. Another one is 9, 0. One initial velocity it doesn't is minus 17, is 17 minus 4, but it's never within it after any step. If you're going to fire as high, you might as well do it with style. How high can you make the probe go while still reaching the target area? The above example, using initial velocity of 6, 9 is the best you can do, causing the probe to reach a maximum y position of 45. Any higher causes it. Find the initial velocity that causes the probe to reach the highest y position and still eventually be within the target area after any step. What is the highest y position it reaches on this trajectory? Alright, so let us just start with, let us, okay, so we didn't use that. I'm just going to noodle here about mathematics. So x, y, d, vx, vy goes to x plus vx, y plus vy. Probe's x velocity changes by 1 towards the value 0. That is, decreases by 1 if it's greater than 0, increases by 1 if it is less than 0, or doesn't change if it's already 0. So does Python have a SIGINT function? Let's see. It does not. So Vx minus SIGINT Vx and Vy minus 1. Okay? And so Now the question is, why would x velocity, let's say, without loss of generality, let's assume Vx is bigger than equal to 0. Well, okay. And so, well, let's say let's just do it by brute force, and then probably in part 2 that won't work. From data classes, import data class. It's data class class probe. It'll start at 0, 0, start equals 0, 0. I don't need that because it's a data class. And def step self. So self.x plus equals self vx, self.y. If self.vx is bigger than 0, self.vx minus equals 1. Elif self.vx less than 0, self.vx plus equals 1. Okay, otherwise it stays 0, and self.vy minus equals 1. Okay, so that's that. And then going back, target area means you define initial xy velocity value such that after any step, probe's x position is at least 20 and at most 30, and the probe's y position is at least minus 10 and at most minus 5. Okay, and so so we know a couple things. One, we know that the okay, so want probe to end up in let's say x low, x, what happened to my thing? X high, and y low, y high at some step. Okay, and so so obviously I want to assume that x is 0, but let me look at my puzzle input and see if that works. Yeah, so x is positive, so that's fine. Okay, without loss of generality, not without loss of generality, but assume that x low is bigger than 0. Then if Vx is bigger than x high, it will go past the target in one step. So necessarily 0 is less than Vx is less than x high. Okay, and now notice that the values of x are 0, Vx, Vx plus Vx minus 1, Vx plus Vx plus Vx minus 2, and so on. Until no, minus Vx plus Vx minus 1 plus Vx minus 2 until the velocity goes to 0. So so I'm trying to figure out what needs to be true about Vy as well. So for each Vx, once Vy is big enough to get it past the target without hitting, Vy can't be any bigger. What I mean is this. If I look at this thing, right, and well, let me look at so let's think about this. Like I need to know when I have either too low. So too low is, you know, if I go below it on my first step, then I'm too low. And if I go okay, so let me just try doing this. Okay, and let's just assert that 0 is less than x low is less than or equal to x high. Probes equals, okay, so for Vx in range, it's got to be 1 up to x high plus 1. That's fine. Okay. Start with the probe that goes up. Lowest possible Vy value goes below V low. So for Vy, I'll just do it this way. Import itertools. For Vy in itertools.count of let me look at what this, how this is written. Y equals minus 10 to minus 5. So if my initial velocity is less than minus 10, Y low, okay, probe equals probe Vx Vy. While true, if x low less than or equal to probe dot x less than or equal to x high, and y low is less than or equal to probe dot y is less than or equal to y high. Okay, probe is append probe and break, so that's true. And if probe.x is bigger than x high, or probe.y is less than y.low, break as well. Okay, and then I want to probe.step. Okay, and then I want to return probes. So say print all probes, and what's their example? 20, 30, minus 10, minus 5. Let's see if that works. Okay, well that doesn't work. So that vx, vy, print probe. All right, let's run this, and it's not stopping. So oh, I say keep checking vy equals true. So while keep checking vy, actually no, let's do all true. If probe, so if I've gone past and probe y is bigger than y high, keep checking vy equals false, break, and if probe.y is less than y low, then I'm done with that probe 2. This needs to be up here, and if not, keep checking vy, break. So let's try it this way. try not printing them and see if that works or if I've screwed up. Actually, I want to print these just so I can keep track of where I'm going. Okay, so clearly my stopping condition is not good. So let's think about this some more. Okay, let me start over again because I don't think this is working. So let me do two things. To have x positions given dx, which is an int, and positions equals 0. No, positions equals this. While true, positions equals 0. Okay. While true, let's say position equals 0, positions equals new position equals positions minus 1 plus dx. Dx equals max of 0 dx minus 1. While dx is bigger than 0, let's put it that way. No, that's not right either. Sorry, having a bad day. Just like yesterday. Well, true. Okay. Def y positions dx dy int goes to list, positions equals 0. Okay. So now we can get x positions and y positions separately. Okay, and def all velocities, x low, x high, y low, y high. And let's see if I can figure this out. If I can't, then I'm probably going to give it up because okay, mapping from okay, number of steps to end up in range. For dx in range 1 comma x high plus 1 for ns pause in enumerate x positions dx if x low is less than or equal to pause is less than or equal to x high, num steps dx dot append ns. Okay, so that will give me the number of steps for each of these that I can do, and then let's print num steps, and let's just try this and see what it does. So if I do 6, I'll be there after steps 5 and 6. If I do 7, I'll be there after 4. Okay, if I do 30, okay, good. So this is slightly more promising. And now what I want to do is and let's say max allowed steps equals max of value for value list in num steps dot values for value in value list. Okay, so this will tell me the most steps I can get, because then I can say, you know, if max allowed steps is 6, then I don't want a y value that is still above the target at step 6. And so we know that the height after n steps is dy, or is vy plus vy minus 1 plus vy minus 2 plus vy minus n minus 1, which equals vy times n plus minus 1 plus 2 plus n minus 1, which is vy times n minus, is that true? If I do 1, 2, 3, so that means n is 4, then that's 4 times 3 divided by 2, so that is true. Okay. So, okay. And what am I trying to find? Initial velocity. How high can you make the probe go while still reaching the target area? Okay. So, turn vy times n minus, yeah. Okay, so now we have is not possibly unbound. So let's try this and see if it works. Unmatched parentheses. Three and none. feel like this is still wrong. So. Max knowledge test is definitely 7, and after 7 it's at minus 14. After 6, 9. So 6, I'm there after 5 and 6, and I feel like I've done something really wrong here. All right, you know what? I'm gonna stop this for now, and I'll come back to it at some point in the future. I'm not making any progress in it, and I'm kind of stuck. So, yeah, not one of my better days. All right, can't all be winners.